begin. So hello everyone, and thank you for joining us today for our safety webinar on how to properly size a shackle to a synthetic sling. My name is Isola Clark. I'm the e-marketing specialist at Columbus McKinnon and will be your host for today's webinar. Presenting today will be Rob Bruno. He's a corporate trainer at Columbus McKinnon, specializing in rigging techniques and inspection, hoisting crane inspection and maintenance, and load securement. Prior to joining Columbus McKinnon, Rob served 6 years in the U.S. Coast Guard on a 225-foot seagoing buoy tender where he was a crane operator, an aids technician, and the primary rigger for lifting applications. After leaving the Coast Guard, he worked for a large wire rope and synthetic sling manufacturer in the Gulf of Mexico. He was responsible for high performance and polyester round sling fabrication, operating a 600,000 K test bed and handling all off-site rigging inspections. He later went to work in sales for one of the largest synthetic sling manufacturers, where he was responsible for assisting customers in the aerospace, nuclear, wind, and hydro industries with selecting rigging for critical lift applications. He's got a lot of experience on this topic. Alongside Rob, we have Henry Brigena. He's our corporate trainer specializing in rigging and load securement. Many of you know Henry. He's been with the company many, many years, has a ton of experience, and he has done numerous webinars, so he'll be alongside Rob, as well as Mike Osborne, who is our global rigging product manager. He'll also be on the call. Before we begin, if you can just advance to the next slide, Rob, please. One more. There we go. I just wanted to let you know, as I said, this webinar is being recorded. Look for an email with the recording to follow in the next day or two via email. Well, yes, a recording with email. It'll give you a link to our YouTube channel. We're going to be allowing 5 to 10 minutes for questions and answers at the end. And the best question or two, we hope to turn into a blog post. And we have a prize, some fun CMCO swag we're going to send to the two people whose questions we feature on our blog post after the fact. So anyway, we really appreciate all of your attention. And now I'll turn the meeting over to Rob so that we can begin. Rob?
Good morning, everybody. Thank you for joining us on this webinar. I appreciate everybody logging on. Some of you on the West Coast, you're just starting out your day, so we appreciate it. Today we're going to go over choosing the proper shackle for use with synthetics using bearing stress calculations. We're going to review the effects of bearing stress on slings, and we're going to discuss some ultimate products that you can use in conjunction with connectionary hardware. And most importantly, before you make any lift, we're going to go over some pre-operational inspection criteria and removal from service criteria per ASME standards. Again, this information is intended for general purpose. None of this is a substitute for any of the government regulations or ASME standards. It's not our opinion. If you have any specific questions, we can definitely assist you and guide you to the right regulations or standards that would apply to that, and we'll be more than happy to help you out with any of those situations. So for our sampling today, to do bearing stress, we're going to use a synthetic round sling, polyester round sling, and a shackle. Two commonly used rigging applications or rigging products that will be used for a standard lift. So with anything, it's very important that you do your pre-operational inspection. Per ASME B30.9-6.9.5 is the removal from service criteria for round slings. What we like to see in the industry is prior to each use, the slings and hardware shall be inspected before they're used. So this is a good thing. So if you run out to your truck or you grab stuff off the crane, you want to make sure you're giving this gear a good look and a once over to ensure that it's safe for you to use and that it's not, it's free from damage and the lift can be made safely. So for the removal from service criteria for round slings, missing or illegible identification, acid or caustic burns, evidence of heat damage, which includes weld splatter, holes, tears, cuts, abrasive wear, or snags that expose the core yarns, broken or damaged core yarns, and again, weld splatter that would burn through the cover and expose the core yarns, Knots in the round sling, except for core yarns inside of the cover. And of course, if you have any fittings or attachments on your round sling, the fittings are pitted, corroded, cracked, bent, twisted, gouged, or broken. And of course, then you'd go on to follow the remove from service criteria for those fittings. Again, this is something that's very important. Lifts are dangerous enough as they are, so you definitely want to make sure prior to each lift or prior to each use, you're inspecting your equipment, especially with synthetics, and you want to make sure that they're free of damage and they're good for you to use. Here's just some sample pictures of common damage you would see in polyester round slings. You know, the tears in the cover, once it goes through both, you know, double walls of the cover and you expose those core yarns, that round sling needs to be removed from service. Any burning, charring, melting of the cover, the sling should remove from service. Naturally, if there's any damage to the interior core yarns, you want to remove that sling from service. Another thing that you also want to take into consideration is UV damage. A lot of times these slings are left in the back of trucks or in job boxes or on the side of cranes. You want to really give the sling a good once over. The sun can definitely damage the sling. You'll start to see discoloration in the covers and stuff like that. You know, you protect your body from the sun. You definitely want to protect your rigging gear from the sun. So that's one more consideration for you to take into account when using synthetics.
Okay, I have a quick polling question we wanted to ask you, and if you can vote, that would be great. If you have an iPad, you can just, you're not able to vote, you can send us your answer via the Q&A pane. But let us know, cut or tear in the cover of a round sling which exposes core yarns is a removal criteria from which ASME standard? Is it B30.9, B30.10, B30.16, or B30.26? We are collecting responses. Give me 1 minute. Again, a cut or tear in the cover of the round sling which exposes core yarns is removal criteria for which ASME standard? Looks like the #1 choice here is, let's see, 71% say B30.9, 14 B30.10, and the rest are divided. What do you think? Can you go ahead and comment on that? Rob, what the correct answer is?
Yep, so the correct answer for remove from service criteria for a round sling is ASME B30.9. .10 covers hooks. .16 is underhung hoist. And .21 would be lever tools.
Perfect. Okay, thank you.
So ASME B30.9 is going to cover all your removal from service criteria on polyester round slings.
Okay, thank you.
71% is a good number, though. We'll take it.
Yes.
So furthermore, in the sampling, we're going to, of course, use a shackle. Very common connection device, pretty much used on just about every lift, or it's on every construction site. Most people use them on a daily basis. And again, we're going to review the removal from service criteria per ASME B30.26-1.8.5. Removal from service criteria for shackles: missing or illegible identification, indication of heat damage, including weld spatter or arc strikes, excessive pitting or corrosion, bent, twisted, distorted, stretched, elongated, cracked, or broken load-bearing components, excessive nicks or gouges, 10% in reduction of the original or catalog stated dimension at any point around the body or pin, incomplete pin engagement, excessive thread damage, any unauthorized weld or modification, and other conditions including visible damage that causes doubt to the continued use of the shackle. So there's a couple key points I really want to stress when it comes to shackles. As I'm going to go back one more slide. The picture on the right-hand side, you could see it's pretty excessive wear, and it's definitely greater than 10%. You really want to focus a lot of concentration in the bearing points of the shackle, what you're hooking it to. A lot of times it's going straight onto your crane hook, or the pins are engaged in hooks, or through eye bolts or swivel hoist strings, or straight to connectionary devices on your load. those are going to be your extreme wear points. I mean, that's where the shackle, you're getting a lot of metal on metal contact. That's where you're going to see a lot of wear and a lot of damage. Another thing we have to keep in mind is shackles are tended to be used and abused. You know, guys throw them around in the back of the trucks. They throw them around on the construction site. You want to treat these things a little more delicately, as nicks and gouges can affect the overall working load limit of the shackle and can cause damage to where the shackle may or fail or prematurely break. So we want to keep a close eye on those things. Incomplete pin engagement. Oftentimes, not every rigging class we teach, we ask this question about turning the shackle pin a quarter of a turn back. It was taught to me when I first got into rigging, and the answer is no. What the regulations and the standards say is you must have full thread engagement, and the shoulder of the pin must be in contact with the body of the shackle. Okay? It's the old wise tale that you turn the pin a quarter turn back because when the shackle comes under load, the pin's going to tighten. That is correct. There's a reason that shackle pins are flat and they have a hole in them for either a marlin spike or a crescent wrench. You want to make sure your pin is fully engaged and the shoulder of the pin is in contact with the body. You never want to go ahead and give that shackle pin a quarter turn back. Another thing you want to keep an eye out for is modifications to shackles. And I'm going to go ahead to the next screen. What you'll see is some good pictures of rejection criteria for shackles. Metal loss or modified. Sometimes the shackle doesn't quite fit, so some people will take a grinder to the inside. You're now modifying the shackle. You're removing material from that. We can no longer guarantee or state what the working load limit is once you go ahead and modify that removed material. Sometimes you'll see the substandard load pin. The guys will lose the pin on the job site, so they'll run down, they'll get a grade 8 bolt from the hardware store, and they'll put it in. And they say, well, the bolt's strong enough to hold up a building. It should be good enough for the load. Well, it's not from the original manufacturer, and we don't know what that pin is rated for. So you got to make sure that you're using the hardware supplied by the manufacturer that coincides with that shackle. And again, there's a better look at the extreme wear and cracking on the wear points of a shackle, on the bearing points. You also want to check on your eyes, warning you longer on eyes. As those shackles are used and the pin's taken in and out, over time that eye will wear down a little bit. It's another area you really want to kind of focus on. Just take a good look at. Here's something we saw in our travels, and we passed by it a couple times, and we finally realized what happened. Is if you can notice on the picture, the pin was actually machined down, and they left just where the pin goes through the shoulder. Sometimes this is done without anybody knowing it, and the shackle's being used. You definitely want to unscrew the pins, separate it from the shackle, and take a good look at the entire assembly as a whole to ensure there's been no modifications or anything like that. Again, once you remove material from that pin, we can no longer state or know what the true working load limit of that pin is. So you definitely want to keep an eye on that and do a thorough inspection, because you just never know what might have been done or what may happen.
Hey,
so
Rob.
Now that we...
Oh, yep. Just one quick point. Could you elaborate a little bit more on the identification requirements? Like what needs to be on the actual shackle in terms of identification?
So on a shackle, the terms of identification is name or trademark of manufacturer, working load limit, and size. Okay. The working load limit is always what you go by, that's stamped on the shackle. The reason for that is, like Columbus McKinnon, we have 3 different shackles: a carbon, a super strong, and an alloy. A 1-inch carbon, a 1-inch super strong, and a 1-inch alloy all have different working load limits. So you always want to go on the working load limit stamped on the shackle, not the size. Because as I just stated, the working load limits will change depending on the material the shackle's made out of. Another thing that comes up quite often is imported shackles. You have to remember it's name or trademark of a manufacturer. If you have nothing but a country stamped on the shackle, that is not name or trademark. Okay, so There's certain imported shackles that don't meet the standards. You want to be careful if you're using those shackles on a job site, as they don't meet ASME B30.26 criteria. That cover it for you, Gisela?
Yes, that's perfect. Yeah. So China isn't a manufacturer. I mean, it's crazy, isn't it?
And that's something you have to be aware of. Like this one says Japan on it. China's a country. Japan's a country.
That's right.
The standard clearly states name or trademark of a manufacturer.
Yep.
So be very careful what you're purchasing and what you're getting in, and do an inspection on that shackle as soon as you receive it to make sure it at least meets the standards before you even use it.
Yeah, that's well said. Those are really, really important points. Okay, I think we have another polling question. Sorry, keep going. I'm sorry. Go ahead.
No problem. Now we're going to get into bearing stress. It's WSTDA 4.7.1.1-4.7.1.3. Bearing stress it's a quick and easy calculation, and as you know, in rigging we do a lot of calculations for load tension, sling angle, center of gravity, calculating overall load weight. This is very commonly overlooked, and it's an important calculation because oftentimes the rigger will go grab a 15-ton sling and he's going to grab the closest shackle to meet that, which would probably be about a 17-ton shackle. And he says, my shackle meets my sling, both meet the load weight, I'm going to go ahead and make my lift. What bearing stress calculates is how much stress that sling's seeing in the working area of the shackle. So what WSTDA recommends for bearing stress value is 7,000 pounds per square inch or less. The calculation, again, it's very quick. It can be done on the fly. It could be done on the field. Everybody has phones nowadays that have a calculator on it. So this is really one that should be done every time a lift is being made with synthetics and connectionary hardware. What we have to remember is the shackle has an actual width and then an effective width. So all shackles have a catalog width that the manufacturer puts out. The effective width is 25% less than that. So you times it by 0.75, your actual width by times 0.75, that's going to give you an effective width. That's the actual width that the sling can use, okay? What that's going to give you is your next calculation would be load bearing area. And basically, once you're done with step one, you take your effective contact width times your hardware diameter, and then that's going to give you the load bearing area. So that's the area where your sling's in contact with. The very last step is you take your sling loads in pounds, you divide it by your load bearing area, and you're going to get a pounds per square inch number. The key to this is you got to remember you want your number 7,000 pounds or less, okay? Over 7,000 pounds, you have tendency to damage the slings, maybe a premature failure, any sort of thing like that. And then when making lifts in our industry, there's so many variables, your equipment, weather, the load, personnel. The more variables we can control and eliminate, the safer our lift's going to be and the more successful we're going to be in that lift. So again, this is just a quick calculation to eliminate one of those variables. So we're going to do a quick sampling so I could kind of run through it with you guys and kind of give you an idea of what this looks like and how to do it. So here's our standard shackle chart for Columbus McKinnon. We're going to use a carbon screw pin anchor shackle, and we're going to go with a 1.5 inch 17-ton shackle. The dimension we're looking at is that B dimension, which is all the way to the far hand right corner, which is 3.50 inches. Okay, that's the actual width of the shackle. So for this calculation, we're going to use a sling load of 29,000 pounds. We're going to use a size 9 round sling, which has a 31,000 pound vertical working load limit. And again, the shackle size is going to be 1.5 inch carbon screw pin anchor shackle, 17-ton working load limit. I chose this selection because we're going to be up there close to our full working load limit of the sling. Okay, so it's going to be very important that all of our calculations are correct. And 9 out of 10 times, you look at this sling load, 29,000 pounds, you pick a little over 15-ton sling, you're naturally just going to grab the 17-ton shackle because everything works out perfectly together. So now we'll go ahead and do our bearing stress calculation. So our actual width of the 1.5 inch shackle is 3.50 inches. We're going to times that by 0.75. We're going to get a 2.625 effective width. Okay, so now we took our actual width, we did our calculation, we have our effective width. We're now going to take the effective width of 2.625 times 1.5 for our hardware diameter, and we're going to come up with a 3.937 load bearing area. Okay, that's what we need now to determine what our PSI is going to be, or our pounds per square inch of pressure. So our sling load's 29,000 pounds. We're going to divide that by our 3.937 load bearing area, and we're going to come up with 7,366 pounds per square inch. As you can see, we're over the 7,000 pound recommended. All right. So what we learned is we took a sling load, a sling, and a shackle load that all matched perfectly. They all fit in line. Nothing was underrated. Everything was above, and we came up with too high of a PSI. So what we'll do next is we'll go up a shackle size. So I'm going to go to an 1 5/8 carbon anchor shackle, screw pin anchor shackle. Okay, now I'm at a 20-ton working load limit, so I'm still well above my load. And I'm going to go to that B dimension, which is my actual width. And I'm going to have a 4.13 B dimension. We're going to use the same scenario, sling load 29,000 pounds, size 9 round sling, 31,000 pound vertical. We're going to use that 1 5/8 carbon screw pin anchor shackle with a 20-ton working load limit. We're going to take our actual width, which was 4.13, times our 0.75. We're going to come up with a 3.0975 effective width. We're going to take that effective width of 3.0975 times the 1.625 hardware diameter. We're going to come up with a 5.033 load bearing area. Now we're going to take our sling load of 29,000, divide it by the 5.033 load bearing area. And you could see now we have a PSI of 5,761 pounds per square inch. Okay, so we've exceeded and we've been below the minimum set forth of 7,000 pounds. What I want to kind of comment on and make note of is sometimes we went up one shackle size. Okay, as you go up in sling capacity, you know, you get into these larger lifts, 70, 80, 90, 100,000 pound lifts or higher. One shackle size may not cut it. You may have to go up 2 shackle sizes, possibly even 3 shackle sizes to get your PSI under 7,000 pounds. So it's not always just going to be one jump up. Depending on the sling load and the size, you may have to go up a couple different sizes to get to where you're under that 7,000 pounds. Okay. Why is this important? Well, it has some severe effects on synthetics. When your PSI is over 7,000 pounds, what they found is it tends to create tears, punctures, rips in the sling cover. It may even, depending on how much it is, cause a sling failure. And again, all those fall under ASME B30.9 removed from service criteria. So as soon as you use that brand new sling in a situation where your bearing stress was too high, you could be removing it from service right away.
Excellent. Thank you. We're going to do another quick poll. This one is the WSTDA recommends a bearing stress of what PSI or below? Is it 9,000, 8,000, 7,000, or 6,000? Again, the WSTDA recommends a bearing stress of what per PSI or below? 9,000, 8, 7, or 6. Oh, it looks like about it's split between 96% Rob say 7,000 and the other 4% say 9,000. What is the correct answer?
The correct answer is 7,000 PSI or below.
7,000 PSI or below. Excellent. Well, we had a very good proportion voting on that. Thank you.
So the next slide, I'm going to cover just some alternatives to the shackle connection. This is something that we've come out with, Columbus McKinnon has come out with. It's the CM Webblock Assembly. Working load limits up to 75,000 pounds. Available in 6 different sizes from 3/8 inch to 1.25 inch, 5:1 design factor, 100% proof tested, meets ASTM and A952 and WSTDA RS1 standards. This is going to be an alternative for connectionary devices on synthetics. As you can see, you have your common hammerlock or connecting link connection up top, and then your orange is a synthetic sling fitting, okay? What that does is if you reference back to the WSTDA standard, you have to deduct part of the effective width, you know, your actual width to your effective width due to the rounded surface. Because that sling connection device is flat, there's no deduction. You get 100% actual width, actual working load of that area. So just by flattening it out, now we take no deduction in width, so we hold full capacity on that. With our Webblock, it's an integrated design, again using the hammerlock coupling link and a synthetic sling attachment. So the hammerlock was that gray piece on top. The synthetic sling attachment was the orange flat bottom. We also did double retention for added safety. So unlike anybody else in the industry, we've gone one step further for that load pin and stud that's on a typical connecting link. So what we did was on the Webblock, we did a double load pin retention system. So we used the traditional bolt and stud. We also gone one step further and extended that bolt, threaded it, and we put a lock nut on that. So there are some concerns in the industry if that stud failed or came loose or cracked off, you know, how do we keep that load pin from sliding out and ultimately dropping the load? Well, we took those concerns and we engineered a device very, very similar. The only difference is we threaded the end of it, and now you have a lock nut. So you have a double retention system. In case for some reason that stud in the middle disengages for any reason, that load pin's still not going to come out. It's very unique to the industry, and I think it's going to be great for added safety to the products and your lifts. As I stated earlier, with the CM Webblock, the sling connection provides full contact surface, being that it's flat. It reduces stress and wear on the sling connection points and allows for better load distribution of your internal fibers on your synthetic slings. Again, on a rounded surface, you have to take that deduction in your width, and then you have bearing stress. With a flat surface, you don't have to concern yourself with bearing stress because you're getting 100% of contact. The hammerlock portion of the Webblock, it allows direct connection to multiple different types of end fittings, such as hooks, shackles, swivel hoist springs, master links, anything like that. So these are very universal in what you can use to connect them to and things of that nature. I did a quick, just to kind of show you where it would come out to, a quick shackle to Weblock comparison. So if we use the sampling of the 1 5/8 screw pin anchor shackle, which had the bearing stress below the recommended per WSTDA, those shackles are 23.5 pounds. To get that same sling load, I could use a 7/8 Weblock, which has a weight of 8.96 pounds. So if you're looking at a 4-leg bridle where you were going to hook up 4 shackles in comparison, you know, maybe to some hooks in comparison to 4 Weblocks, I mean, you're looking at about a 60-pound difference in weight by using Weblocks. Because of that flat surface, you know, we could use a smaller diameter and a smaller Weblock in comparison to the larger shackles due to the bearing stress. And again, as I mentioned earlier, the Weblock is going to reduce wear on your connection points of your sling, 100% of the actual width, and the shackle loses 25% of that width. One of the great things about Weblocks, where I've seen them used in applications, is a lot of places are going to dedicated lifts. And what that means is they buy a 4-leg bridle to lift a particular part. That bridle stays in that job box at that part. That's all it's used for. What's nice about the Weblocks is you never have to worry about somebody going in there and unshackling a sling because they can't find one around. You know, the Weblock's going to make that a semi-permanent to permanent connection. The also great thing about Weblocks is, you know, you can put just about all your connectionary devices directly into them into that hammer lock, your hooks. So you don't have to worry about bearing stress on that. It's going to reduce your wear on your synthetics. So you might get some longevity out of the use of your synthetics that normally are connected directly into a hook or a swivel hoist ring or a master link. Now you can connect up with a Weblock connector and maybe extend that life a little more because you're going to reduce that wear on the connection point. And that's it for me. Any questions?
Oh, we have a lot of questions, a lot. So thank you all for typing them in so diligently. We got a lot to cover, so we still have 10 minutes, which is great. First of all, well done, Rob. You covered it. You covered the material excellent. And here is question number 1. So would it be acceptable to use a web sling on a common shackle as long as the sling safety factor is not infringed upon?
Yes. So I think what they're asking is maybe D over D ratios for synthetics. Synthetics aren't like wire, rope, or chain. There's no recommended D over D on synthetics. What you have to take into consideration is this bearing stress factor. So majority of the time, again, you're going to grab a 10-ton synthetic, you're going to grab a 10-ton shackle, and they work perfectly together. Completely fine as long as your bearing stress on the synthetic is 7,000 psi or less. There is no D over D ratio or deduction for synthetics.
Okay, great, thank you. What is the criteria for removal involving UV damage?
That's a very tough question to answer. There is no percentage of UV damage. There's no, it's basically going to be on the inspector to use their best judgment of the continual use of that sling. There's been, WSTDA has done numerous testing on UV degradation, and they have testing samples of slings left out for 12 months, 24 months, 36 months. But again, depending on where you are, how much that sling's exposed to UV light, the discoloration of the sling, it's really the inspector's job and judgment call to continue the use of that sling or remove it from service. Okay, yeah, that's a tricky one. I got Henry here, so.
No, you're good. You're good.
Henry, do you have any comments to add?
No, Rob's correct. There's when you do suspect UV damage, and that's pretty obvious, is the sling will start to get discolored. If you had like a purely yellow sling and compared to a new one, and it's nice and yellow, and this one will be like almost like a beige or even a white color, that's usually a really good indicator. Also, if it starts getting, when you touch it, you'll get like a little film will come off in your hands. It almost starts to turn to dust. Those things are real good indicators that UV is damaging your sling.
One of the easier things with polyester round slings is usually they're color coded. You know, you got your purples, your greens, your reds, your yellows. When those colors start to fade to a white or a very faint of its original color, that's a good sign that most likely you have a substantial amount of UV degradation on the sling.
Okay, excellent. Thank you. All right. What is the B30.26-1.8.5 then? Is that part of B30.9?
No. So B30.9 is that ASME standard covers slings. ASME B30.26 covers rigging hardware, so eye bolts, links, shackles, those type of attachment points. So I reference the exact ASME B30.26 standard where you'd find removal from service criteria for shackles.
Okay, excellent. Thank you.
I just want to throw in one quick thing. It kind of just came to me as we're talking about shackles and slings. One of the other big things with the, and I'm going to go back a couple slides, right? This one. One of the big things about bearing stress with shackles and the difference between the shackle and the Weblock connector is a lot of times when you use a shackle to a synthetic or a polyester round sling, you tend to get bunching inside because you're using too small of a shackle for the size of the round sling. Even though the weights match up perfectly, you know, 10-ton shackle, 10-ton sling, that sling is all bunched up and condensed in there. That's causing your bearing stress. Also, that bunching causes the sling, usually causes damage to the sling. You're pinching that cover, you're going to end up tearing that cover, which ultimately could potentially damage your core yarns. Whereas if on a Weblock with that 100% flat surface, that sling evenly distributes itself along that and you get no bunching. So again, the difference is you're going to get a little bit longer sling life if you take care of it and you inspect it properly, going with a Weblock style connection area device than a shackle. I think the biggest thing is when you're connecting hooks, you'll get a lot longer life out of your synthetics if you use a Weblock to that hook rather than putting the hook directly on the synthetic.
Okay. Okay, excellent. Should shackles be magnafluxed?
Not unless it's your own company's requirement. There's nothing in any standards or anything that states you need to do that. If your company or your division requires that, by all means, you're going above and beyond the standards, but none of the standards require you to do any of that to shackles.
Okay. Working in entertainment, often we're trying to hide our rigging equipment so it blends in. Is there any issue related to spray painting shackles?
Well, I got a very easy solution, and I'll save you money without spray painting, and I'll keep your hands clean. We offer a full entertainment line of shackles, which are already powder-coated black, so you could save yourself a lot of trouble. It's going to look just like our regular carbon screw pin anchor shackles, our bolt nut cutter shackles, but we take care of painting them black for you.
Yeah, that's great. Now we can definitely include a link to the CM Entertainment website. Well, it's basically I believe it's cmet.com.
Yep. So we'll save you the trouble of going to Home Depot and buying that spray paint.
Okay. All right. So there's a few more questions. Now, I know we're getting close to the end, so bear with us 5 more minutes. We'll take a few more questions, and then we'll wrap up. So our project requires serial numbers for shackles for inspection tracking purposes. We have problems keeping tags in place. What is a viable method of providing a serial number on a shackle?
CM does provide a pad on the shackle that can be engraved. The instructions are on our website as far as what it takes to engrave them or stamp them. But yeah, or we could do it for you. But we could do that. Obviously, we'd have to know about it first and give us the information. But yeah, that can be done. I would not recommend just doing it on your own, though. I would contact the manufacturer, find out what their requirements are for doing that. But I know we do have some shackles that have a raised pad surface just for that purpose.
Yeah, I think we have a blog covering that as well that we could share. Is there a requirement to periodically load test shackles?
There is no requirement to periodically load test your shackles. Again, if your individual company requires you to do that, then by all means you should follow it. But as far as the standards and regulations go, there is nothing that says you need to periodically load test your shackles.
Okay. How do you do the bearing stress calculations when you're dealing with a bridle? The calculations appear to be directly related to inline loading and does not appear to account for a basket or bridle connection. Does the necessary width double to account for 2 slings being attached to the bell of the shackle?
Nope. So all the calculation covers, it basically cares about the sling load going in that shackle. So if I was going to take that same shackle, that 1 5/8 or 1.5 inch shackle, and run a basket through it, I would just double my sling load through that shackle. If you're going to put 2 slings in it, then again you're going to go both sling loads into that shackle. You're not really taking into consideration, you want to make sure you're within the 120 degrees of the included angle to rig in the shackle, but you don't take any deductions for angles in the bearing stress calculation. It's all based on sling load. Is that kind of?
Yeah, I think that's good. Okay, a couple more. Why is it not allowed to reeve the sling through 2 horizontal placed shackles?
Can you read that again?
One more time.
Why is it not allowed to reeve the sling through two horizontally placed shackles?
The same sling?
I'm assuming. This is from Richard. Richard, could you maybe clarify your question if you're still on the call a little bit further? Okay. Let's see. How do you size shackles when using a round sling in a reverse basket?
Okay. So you're gonna basically, again, you want to do this bearing stress calculation. So I think what they're referring to is maybe an inverted basket, which is becoming a pretty common hitch in our industry. There's a couple things you want to remember when doing an inverted basket. One, you never want to put the sling on the pin of the shackle, okay? Because the reason people run inverted baskets is it helps them find the CG of the load. So you want to make sure you're not putting the sling on the pin of the basket, on the pin of the shackle, because naturally you could disengage the pin. So you want to be on that bail. But now remember, you just doubled your lifting capacity in a basket. So if you have the shackle, you want to run your bearing stress on that basket capacity. So if you had a 30,000-pound sling, you're going to put it in a basket and now you're at 60,000 pounds. That's what your load is going to be, your sling load for the bearing stress calculation. So you're going to run it the same way as you did if you were picking up vertically. You're just doubling your sling load.
Okay. Okay, so we're gonna take the two more questions, and then Rob will personally email the rest. We have a few more after that. I'm sorry, our big rules, we don't ever like to keep people beyond our time. So I guess when the question came up, why is it not allowed to reeve the sling through two horizontal placed shackles? You asked a question, and he said yes. So however you understood that to be, that's how he was intending it, if that helps.
Okay.
They're on the same plane.
I'm thinking, I'm hoping that they're both on the same plane, and if you're reading a endless sling through the same between the two shackles, you're pulling it on a 90-degree angle as far as going through a shackle. I'm not quite sure you're going to want to do that, because the orientation of the pin is going to be very, very important. If the pin is at a 90-degree angle to the tension load, you're actually going to be pulling on the side of the shackle at 90 degrees, which is not acceptable. You're going to want to make sure that that shackle goes in the other orientation so that the shackle can actually pivot on the pin properly. So without actually seeing more information about it, I'm not quite sure how else we could answer that.
If we didn't answer that one for whoever put out the question, if you want to send a quick napkin sketch or a little drawing to my email so I could kind of visualize it, sometimes that helps out, and we'll be more than happy to answer that question directly to you. And
yes, I will let you know. I will let you know who it is. Yes, perfect. Okay. Well, as I said, we have a few more questions, but we have to go now and continue. Rob, can you just wrap it up? And then, like I said, Rob will personally get in touch with those of you who still have. So again, this is Rob. If you have any direct questions to him other than those that you've typed up, please feel free to reach out to him directly, and we can go from there. Let me just see one thing quick. This is how you can reach him. It's very kind. Yes, we'd love to. I mean, I'll tell you what, we are welcome to stay on and take all the questions for anyone who would like to still stay on. We just don't want to keep you beyond your time. Seems like there's a lot of interest. So I'll tell you what, we'll just continue. And if anybody needs to drop off, you can drop off. I just do want to share one more thing before we continue with the questions then. Rob, if you can go to the next slide, I just want to cover a little bit of the training that we offer. For those of you who are unfamiliar with our training classes, we have extensive training classes. You can find them all at training.cmworks.com. Our main website is cmworks.com, so it's just training before that. We have a rigging class coming up in June, a rigging and crane operator, train the trainer in August. We have an overhead crane hoist inspection class coming up in Charlotte, where I'm located, as well as several different online classes that we offer. So we offer classes in different sites around the country, and we have a lineup all the way through January of next year. So please feel free to reach out to us and look at what we have to offer that might be able to help you learn more about a lot of the subjects that we've been covering today. But let's go ahead and finish taking all the questions, because I know this is something, if you're willing to stay on, we are glad to have you. Okay, we've got that one. One point that came up was, let's see, how to easily determine if the knots inside a round sling are normal or not, since there is a cover over the core yarns. This seems to be very tricky in the industry.
Yeah, so this is something as a coming from fabricating round slings and coming from the synthetic world, I got asked a lot. We get asked a lot in our training questions. It is difficult, and the best way I can explain it is when round slings are made, it's a continuous circle of load-bearing core yarns, okay? Oftentimes, when they finish running the sling or when they start running the sling, they tie knots in it just to secure everything, okay? Depending on the size of those slings, they could be, on your smaller slings, your purples, your greens, even your yellows, those knots are very tiny, okay? On your larger slings, they're very large. Usually when a polyester sling fails, the friction inside of those core yarns from heating up and being under that load is going to shoot back in that sling, and it's going to be what they call a knot. It's going to be like a solid type of, more like a golf ball feeling. It's going to be very hard. You're not going to be able to maneuver it in your fingers too well. Whereas if it's a finished knot or a beginning knot, you can kind of roll that around and feel it flex and move. When the sling fails, you're not going to be able to do that. Also, a key sign that there's a failure in a polyester round sling is think of a snake swallowing a mouse. You see the mouse going down the body. You're going to see that same kind of thing in a polyester round sling usually. It's very difficult. The only thing I could suggest for you to get better at it is to continually inspect them and feel the differences. And if you could get your hands on a broken round sling and really train yourself to feel the difference between the two. Other than that, it is very tricky. It's very difficult to decipher the difference, but it's something that just comes with a lot of practice. Key signs too is if there's any other damage to your round sling. Is your cover torn? Are there burns and stuff over there? That's usually going to indicate too to maybe an overload situation, and you'll feel things differently than a sling straight out of the box.
Okay, excellent. I'm just going to go back to this one question. I think we asked, and I'm trying to remember, why is it not allowed to reeve the sling through two horizontally placed shackles?
We talked about that one, Gisela, and he's
going to send us a little bit more information, correct?
Yeah.
Okay, perfect.
Yeah,
I just want to make sure. Okay.
We'll be able to help him out.
Okay, perfect. Okay, then the last couple comments are, it was brought up by our product manager that you might just want to touch on the fact that the color codes for the round slings aren't mandated here in the U.S. They're only standardized in Europe. So I guess the point is, don't assume a particular color in the U.S. represents a particular working load limit, as the standards are actually mandated in Europe. But yeah, you want to just speak to that, Mike? A little bit, Rob?
Yeah, so that's 100% correct. We've kind of adopted that in the U.S., but by no way, shape, or form do you refer to the color of a round sling per its capacity. Per WSTDA, it's actually size 1, 2, 3, 4, and so on. That's why it's key to never use any sling without a tag, because you have no idea how that sling was created or what it was made to. So very much so, I could fabricate a yellow polyester round sling where it could have one working load limit, and somebody could fabricate it in a yellow cover across the country and have a completely different working load limit because it's not standardized. So definitely always go by what the tag says on the actual sling. It goes for anything. On hardware, if you're using shackles, always go on the working load limit stamped on the shackle. Swivel hoist springs, eye bolts. Manufacturers manufacture things differently. And just because a 1-inch eye bolt has this rating by one company doesn't mean every company follows that same rating. That's why every single removal from service criteria in our industry per all ASME standards is missing or illegible identification or tag is #1 on the list. That's whenever I did a sling inspection or a hardware inspection, I started right there, because if it wasn't there, there was no reason to waste my time and go any further, because just get rid of it right away.
Okay, excellent. Okay, final comment. There was just one thing that came up. Is the concern how the core yarn runs across the bearing area, perhaps in regular curve, shackle, or hammerlock? Not all the yarn sees the load at the same time or 100%, but in the flat that you feel the yarn will see the load evenly. Does that make sense? Okay.
Yeah, and that's kind of where they developed the bearing stress calculation was
Okay.
you have to take what the actual width is and you have to get where the sling's actually going to sit. Now, can I tell you all the core yarns aren't seeing equal load? I don't think anybody can, because it's going to depend on each and every sling. Can I say that there's more likely of a chance or a better chance that on a flat surface, those core yarns are going to load more equally and be evenly distributed across that surface? Yes, I can say that. So again, it's a case-by-case scenario. Nobody could ever tell you one way or the other, but just per what the standard reads is you have to take that deduction in your shackle to make sure that you're in the load-bearing area of the shackle. Again, that area is much smaller than the actual width of the shackle. On a flat surface, you're using that whole span. So, you have 6 inches for that sling to stretch out across and the core yarns load equally and distribute equally. Whereas in a shackle, you're not sure. So again, that goes to the longevity of the slings, how the slings are used. There is no bearing stress on a flat surface as in comparison to a curved surface. So I hope that answered the question.
Yeah, no, excellent. Thank you so much. Can you just go, a couple quick things came up I just wanted to speak to. The first one is if we're able to provide slides. We don't provide slides from these sessions because there's so much commentary that's made, but we do provide you a link to the YouTube video so you can watch the whole thing in its entirety. So like I said, you're going to be getting that by tomorrow today's Friday, so Monday at the latest. And okay, can we go to the last slide, please? I just want to speak to our social media where you can learn more about what we do. So I just want to let you know we're very active on social media. We have a blog with over 200 technical articles, a lot of which covers what we talked about today. As well, we're active on Twitter. We have an entertainment channel as well as another channel for our industrial group. We have our YouTube channel. We're on Facebook, LinkedIn, Google+, Instagram. So if you are any of those channels, follow us there, follow the conversation. We love to engage with you there. And we just thank you all for participating today. Have a great weekend. And again, if you have any questions, you will be getting a follow-up email from us with a link to the webinar. Feel free to respond. It'll come from me and I can forward it on to Rob if you have any further questions. So thanks again for everything and have a great weekend. Bye-bye.
Thank you, everyone.